Hi guys, my name is ANIRUDH and we are going to be talking about partition-based OS, which also comes under memory management. There are two types of memory management techniques, namely contiguous and non-contiguous. Contiguous memory allocation is a memory allocation method that allocates a single contiguous section of memory to a process or a file. This method takes into account the size of the file or a process and also estimates the maximum size up to what the file or process can grow. Taking into account the future growth of the file and its request for memory, the operating system allocates sufficient contiguous memory blocks to that file. Considering this future expansion, the file's request for memory, the operating system will allocate those many contiguous blocks of memory to that file. The main memory has to accommodate to both the operating system and the user space. Now here, the user space has to accommodate various user processes. Now the question arises, how to allocate the available memory space to the user processes that are waiting in a ready queue. In contiguous memory allocation, when the process arrives from the ready queue to the main memory for execution, the contiguous memory blocks are allocated to the processor according to its requirement. Now, to allocate the contiguous space to user processes, the memory can be divided as fixed sized partition or in the variable sized partitions. In this section, we will discuss contiguous memory allocation in a detail along with its advantages and disadvantages. So let us start. Fixed size partition. In the fixed size partition, the memory is divided into fixed size blocks and each block contains exactly one process. But the fixed size partition will limit the degree of multi-programming as the number of partitions will decide the number of processes. So size of the partition can be different. As it is contiguous allocation, hence no spanning is allowed. Here, partitions are made before execution or during system configure. As illustrated in the above figure, first process is only consuming 1 megabyte out of the 4 megabyte in the main memory. Hence, internal fragmentation in the first block is 4 minus 1, that is 3 megabytes. Sum of the internal fragmentation in every block considered will be 7 megabytes. There are some advantages and disadvantages of fixed partitioning. Advantages of fixed partitioning. Easy to implement. It simply requires to put a process into certain partitions without focusing on the emergence of internal and external fragmentation. Little OS overhead. Processing of fixed partitioning require lesser access and indirect computational power. Disadvantages of fixed partitioning. Internal fragmentation. Main memory use is ineffective. Any program, no matter how small, occupies an entire partition. This can cause external and internal fragmentation. External fragmentation. The total unused space of various partitions cannot be used to load the processes even though there is space available, but not in the contiguous form, as spanning is not allowed. Limit process size. The process of size greater than the size of partition in main memory cannot be accommodated. Partition size cannot be varied according to the size of the incoming process's size. Hence, the process size which is greater than the partition block will be invalid. Limitations of degree of multiprogramming. Partitions in main memory are made before execution or during system configure. Main memory is divided into fixed number of partitions. The popular algorithms used for allocating the partitions to the arriving processes are first aid algorithm. This algorithm starts scanning the partitions serially from the starting. When an empty partition that is big enough to store the process is found, it is allocated to the process. Obviously, partition size has to be greater than or at least equal to the process size. Best fit algorithm. This algorithm first scans all the empty partitions, then it allocates the smallest size partitions to the process. Worst fit algorithm. This algorithm first scans all the empty partitions, then allocates the largest size partition to the process. Now let's go to the next type. Variable partitioning. It is a part of the contiguous allocation technique. It is used to alleviate the problems faced by fixed partitioning. In contrast with fixed partitioning, the partitions are not made before the execution or during system configure. Initially, RAM is empty and the partitions are made during the runtime according to the processor's need instead of partitioning during system configure. The size of partition will be equal to incoming process. The partition size varies according to the need of the process so that the internal fragmentation can be avoided to ensure effective and utilization of RAM. The number of partitions in RAM is not fixed and depends on the number of incoming process and main memory size. There are some advantages and disadvantages of variable partitioning. Advantages of variable partitioning. No internal fragmentation. In variable partitioning, space in main memory is allocated strictly according to the need of process. Hence, there is no case of internal fragmentation. There will be no non-used space left in the partition. No restrictions on degree of multiprogramming. More number of processes can be accommodated due to the absence of internal fragmentation. A process can be loaded until the memory is empty. No limitation on the size of the process. In fixed partitioning, the process with the size greater than the size of the largest partition could not be loaded and the process could not be divided as it is invalid in the contiguous allocation technique. Here in variable partitioning, the process size can't be restricted since the partition size is decided according to the process size. Disadvantages of variable partitioning. Difficult implementation. Implementation variable partitioning is difficult as compared to fixed partitioning as it involves allocation of memory during runtime rather than during system configure. External fragmentation. There will be external fragmentation in spite of absence of internal fragmentation. Operating system uses the following memory allocation mechanisms. Main memory usually has two partitions, low memory, which operates system resides in its memory. High memory, user processes are held in high memory. Single partition allocation. In this type of allocation, relocation register scheme is used to protect user processes from each other and from the changing operating system code and data. Reallocation register contains value of the smallest physical address, whereas limit register contains range of local logical addresses. Each logical address must be less than the limit register. Multiple partition allocation. In this type of allocation, main memory is divided into a number of fixed sized partitions where each partition should contain only one process. When a partition is free, a process is selected from the input queue and is loaded into the free partition. When the process terminates, the partition becomes available for another process. The other type of technique, non-contiguous memory allocation. Non-contiguous memory allocation is basically a method on the contrary to contiguous allocation method. Allocates the memory space present in different locations to the process as per its requirements. As all available memory space is in a distributed pattern, so the freely available memory is also scattered here and there. This technique of memory allocation helps to reduce paging and segmentation are the two ways which allow a process's physical address space to a non-contiguous. It has advantages of reducing memory wastage, but it increases the overheads due to address translation. It slows the execution of the memory because time is consumed in address translation. Paging is a storage mechanism that allows OS to retrieve processes from the secondary storage into the main memory in the form of pages. The pages process should be protected by using the concept of insertion of an additional bit called valid or invalid bit. The biggest advantage of paging is that it is easy to use memory management algorithm. Paging may cause internal fragmentation. Segmentation. method works almost similarly to paging. Only difference between the two is that segments are of variable length, whereas in the paging method, pages are always of fixed size. You can achieve sharing by segment referencing multiple processes. Segmentation is costly memory management algorithm.